Hi everybody and welcome to our review for section 7.4. Let's get started. Go to our first slide here. Alright, so as usual we'll go over maybe some definitions and then we go over examples. Alright, so recall from section 7.2 that a uniform sample space is a sample space in which the outcomes are equally likely. So you can go back to our video for 7.2 to review what that is and look at some examples, right? But the assumption is that for this section 7.4, we're just going to assume that we're working with uniform sample spaces, right? So given such a space S, then we see that the probability of an event E is equal to the number of outcomes in E divided by the number of outcomes in S, right? And remembering that S is like the universal set here, and then E is a subset of S, this is kind of just like the problems that involved counting in chapter 6, except we're just dividing the number of ways to count certain things, right? And when we see an example, hopefully it will make more sense, but really every problem just comes down to you figuring out the number of elements in E, dividing that by the number of elements in the entire sample space. So let's look at an example like that. Here's our first example. This is WebAssign number 6 in 7.4. Alright, so 4 balls are selected at random without replacement from an urn containing 3 white balls and 5 blue balls. So let me go ahead and write that down. So you get 3 whites, 5 blue, and of course you can see that this is a total of 8 balls. Alright, that's the first piece of information. Alright, so we know that we're selecting 4 out of the 8 balls total. But let's read on so that we can see exactly how many of each we have to select. So we're wanting to find the probability that 2 or 3 of the balls are white. And okay, so now we want to round our answer to 2 decimal places. So we're trying to find the probability that 2 or 3 are white. Okay, so what you want to do here first is you want to define the event. So let's say let E be the event of selecting 2 white balls. And then let F be the event of selecting 3 white balls. Right, so we have these 2 events and we want to find, so the question really here is find the probability of E or F. Then you have to ask yourself, okay, E and F, are these events mutually exclusive, yes or no? So essentially, can they happen at the same time? The answer is no, they cannot happen at the same time because you either choose 2 balls or you choose 3 balls. Well, cannot happen at the same time. It's one or the other. So yes, these are mutually exclusive, which means that we know that the probability of E or F is going to be equal to the probability of E plus the probability of F. And that's because the probability of E intersect F is 0 because that's the empty set. So they have nothing in common, right? So now that we know this information right here, it suffices to find the probability of E and then adding it to finding the probability of F. So remember that whole formula where we have to find, for this one right here, probability of E, we have to find the number of elements of E and then divide that by the number of elements in the sample space. And then for F, same thing. We have to find the number of elements in F, or the number of outcomes in that event, divided by the number of S. So once we figure out what those quantities are, we'll add them together and that will be the probability that we want. Okay, so we'll start with the number of elements in S, right? So how many outcomes are in the entire sample space? Well, let's write it down over here. So we want to find n of S. Okay, so remember what we were doing here. We have 8 total balls, and we're selecting 4 out of them. Right, so that means that we're counting the number of ways of selecting 4 balls out of a total 8. And typically for problems like these, you can assume that the order of choosing these balls, right, whether blue first or white next, it doesn't matter. We can assume that the order doesn't matter. So we're trying to find the number of ways of picking 4 items, 4 balls in this case, out of a total 8. So if you remember from chapter 6, we can use combinations and say, hey, we're just choosing 4 out of 8. So you'd have your 8 NCR4, and that will be the number of outcomes in the sample space, right? So this is equal to that, right? So this is going to be the denominator in our probabilities here would be 8 choose 4. Okay, we got that. Next, we want to find, let's say we find N of E first. So we want to find the number of outcomes of, in the event of selecting 2 white balls. Okay, so the way you want to think about this is, okay, I'm choosing 4 white balls. Sorry, I'm choosing 4 balls total. I want to choose 2 of them to be white. 4 balls total, 2 are white, which mean that 2 are white, and then I need 2 more, so, well, there's only white and blue balls, which means that the other 2 have to be blue, right? And then you just want to count the number of ways of choosing 2 white balls and 2 blue balls. Okay, so now remembering that we're choosing 2 white balls out of a total of 3, and we're choosing 2 blue balls out of a total of 5. So the number of ways of doing that is, so you say N of E is gonna be equal to, we're choosing out of 3, 2, times the number of ways you can choose out of a total 5, 2 again. Right? So this right here is N of E. And hopefully that makes sense. And then we do the same thing for N of F. Alright, so remember now the event F is the event of selecting 3 white balls, which means that we're selecting 3 whites. We have to select a total of 4, meaning that one of them has to be blue this time, right? So N of F is gonna be equal to, all right, so how many white do we have? 3, and we're choosing all 3 of the white balls, 3 out of 3, so 3 choose 3, times, and now the number of selecting the blue balls, of which there are 5, but you're choosing only 1, so you multiply these combinations here. So finally, the probability of E or F, so that means, that's supposed to be an F, not an R. Probability of E or F is going to be equal to, remember, this is the probability of E plus the probability of F, meaning, so now we want to do C32 times C52 divided by C84, that's N of S. So that's the probability of E plus, and then the probability of F, you get C33 times C51 divided by C84. So once you add these two probabilities, you have the probability of selecting 2 or 3 white balls. And when I did this, I got 35 over 70, or 1/2. If I have to round to 2 decimal places, that's 0.50. Right, so there is a 50% chance that I can select 2 or 3 white balls out of an urn that has 3 whites and 5 blue. So hopefully this makes sense. Let's look at another example from 7.4 over here, and let's erase all of this. Okay, here's our next problem. So number 9 on web assign. A shelf in the Metro department store contains 8 colored ink cartridges for popular inkjet printer. Okay, so most important information here, we have 80. I think I said 8, but we have 80 total. And then we're told that 8 of them are defective. So 8 are defective. Right, so whenever you see a question like this, you ask yourself, okay, so let's see, what information do I have so far from just this? We have 80 total, 8 are defective, which means that 72 of them are not defective, right? So 72 are good, 8 are bad, 80 total. All right, now let's look at what the question is asking us. And we have to round to 5 decimal places. So part A says if a customer selects 3 cartridges at random from the shelf, what is the probability that they are all defective? Okay, so we're selecting 3. We're asking ourselves what is the probability that they're all defective. Okay, so we do that whole thing again, right? So we say, okay, let E maybe, just standard, be the event of selecting 3 defective cartridges. So that's defective cartridges here. So E is the event that we select 3 cartridges, and E is really just the event of the thing that you're looking for in the question, right? We says that we're looking to select 3 of them that are defective. Let that be your event E. Okay, so now we want to figure out what the number of elements in E is, and then what the number of elements in the entire sample space is. Okay, so now let's talk about N of S. I just like to do that one first. Okay, so for N of S, so you have to ask yourself, what is this problem? So regardless of what kind of cartridges we're picking from the shelf here, what is it that we're doing ultimately? Well, ultimately, we're choosing 3 things out of a total 80 things. So you want to think about it that way. That's the number of total possibilities. So we're selecting, so I'll say select 3 cartridges out of 80 total. And we want to count the number of ways that we can do that. Well, this goes back again to chapter 6. Assuming the order doesn't matter here, we're just choosing any 3 out of 80. That means we want to use combinations C83 or 80 and CR3 in your calculator. So that will be the denominator of our fraction for the probability. Let's find N of E, so the number of elements in the set E, or the number of outcomes in E. That's us choosing 3 out of the 8 defective, right? So we know we have 8 defective and we want to choose 3 out of that set. So that means we want to select 3 out of 8 defective. And then again, we can use combinations to do that. So you'd say the number of outcomes in E is equal to, how do you choose 8 things out of 3, assuming the order doesn't matter? Other way around, how do you choose 3 things out of 8 things, assuming the order doesn't matter? And then you end up with the probability of E is then equal to, right, N of E over N of S, which is equal to 8 choose 3, I'll say NCR now, divided by 80 NCR 3. Alright, so enter that into your calculator and this is what you'll get. You'll get this is approximately equal to, running out of space here, 0. And then 0.0068. Right, so this is our answer to 5 decimal places. Right, so there is a very, very small chance that you will choose all 3 that are defective out of the 8 if you're just choosing 3, which hopefully makes sense. And then the second part. Now, if a customer selects, again, we're still choosing 3 out of the total 80. So if you're asking yourself, okay, how many elements in the entire sample space or how many outcomes in the entire sample space, it's still the same. it's still gonna be 80 NCR 3 or 80 choose 3 because we're still choosing 3 out of 80. But we're being asked what is the probability that at least one is defective. Okay, so you have to ask yourself, what does at least one mean? Well, we're choosing 3, so at least one means either 1 or 2 or 3, right? So maybe let F be the events of selecting at least one. Again, that means 1 or 2 or 3. That's what at least means, right? So that's that event. And we're trying to find the probability of F. So then you have to ask yourself, is it easier for you to find the probability of selecting one defective, and 2 good ones, plus the probability of selecting 2 defective and 1 good one, plus the probability of selecting 3 defective and 0 good ones, and adding up all those probabilities? Or is it easier to do 1 minus the complement of that? And the way I'm asking the question, hopefully, it's pretty clear that I want you to lean towards 1 minus the complement, right? So what I mean is this. So if you recall, by the rules of probability, the probability of the complement of an event is equal to 1 minus the probability of that event. And I'm saying that it's easier to do it this way because now you're doing 1 minus and you're only subtracting one factor here, the probability of E, instead of finding 3 different probabilities and adding them up together, right? Because if the numbers were larger, so for example, if you were selecting 10 cartridges and it said at least 1, you'd have to add the probability of 1 plus the probability of 2 plus the probability of 3 plus all the way to the probability of 10, instead of just doing 1 minus the probability of the complement of that. So it's usually easier for problems like these to use subtraction rather than to add up all the possible cases. So that's what we're gonna do here. So what you have to ask yourself is, all right, so the probability of F, which is what we're looking for, is equal to the probability of at least 1. All right, is equal to, so we want to do 1 minus the complement of at least 1, or 1 minus the complement of the probability of that. So 1 minus the probability of, right, so what is the complement of at least 1? Well, at least 1 starts at 1 and up, so the complement of that will just be 0, right? So that means the probability of 0 defective. So that's what I think about it is, what is the opposite of at least 1 defective? Really, it's 0. It's no defective. So we want to do 1 minus the probability of 0 defective. Well, that's the same thing as saying 1 minus the probability of 3 good ones, or 3 non-defective. So you can think of it that way. So in order for me to find the probability of at least 1 defective, I can do 1 minus the probability that all 3 are good, or all 3 are non-defective, meaning 0 of them are defective. Okay, now let's ask ourselves, okay, so how many non-defective, or good as I call them there? Okay, so then we go back. We knew that we had 80 total and 8 of them are defective, meaning that 72 are non-defective, right? So 72. So now we count. So counting the number of ways to select 3 good ones out of a total 72 good ones. Again, that's combinations because we're assuming the order doesn't matter here. So we're choosing 3 out of a total 72. And then we put everything together. So the probability of F, which is what we're looking for, is equal to 1 minus, all right, and then we'll have this fraction 72 choose 3 divided by the number of elements in the sample space, which is the same as in part A, that's C83. And once you do this, you get that this is approximately equal to 0.27410, right? So 5 decimal places. So it definitely increases the probability, right? You went from having a very small probability of choosing all 3 defective to now at least one, you have about a 27% probability of choosing at least one that's defective. So hopefully this helps, and this is all I have for 7.4. I will see you in the next section.